In 1905, Albert Einstein proposed the photon hypothesis, suggesting that light, which was previously thought to be a wave, electromagnetic wave, also possesses particle-like properties. Conversely, in 1924, Louis de Broglie proposed that if light has particle properties, then particles with mass, such as electrons, should also possess wave-like properties, wavelength. This wave-like nature of particles is called a matter wave, or a de Broglie wave. Matter waves were later proven through experiments, such as electron diffraction. This concept led to the further development of quantum mechanics, including Schrödinger's wave function. An experiment can be conducted by replacing the photons in the double-slit experiment described in Chapter 4 with electrons. When electrons are emitted toward a double slit one by one, a similar interference pattern appears. The mysterious phenomenon where a single electron passes through two slits simultaneously and behaves as if it were interfering with itself was confirmed by Akira Tanimura and others in their 1989 Electron Double-Slit Experiment. This phenomenon is caused by de Broglie's matter waves. The wavelength of a matter wave is expressed as the wavelength lambda is equal to Planck's constant h divided by the momentum p. By combining this with the Planck-de Broglie relations, energy equals h bar times the angular frequency omega. The momentum p is h bar times k, the wave number. Two different wave velocities appear for a particle with mass: phase velocity and group velocity. Phase velocity is the speed at which the individual peaks, phases, of the wave progress. Group velocity is the speed at which the beat, wave packet, or pulse, formed by the superposition of several waves progresses. In quantum mechanics, the clump of energy or information where a particle actually exists moves at this group velocity, and the classical velocity of a quantum coincides with the group velocity. In quantum mechanics, particles are viewed as a superposition of probability waves. Just like photons, the probability waves of electrons pass through both slits simultaneously and interfere, causing an interference pattern to appear on the observation screen. In our space theory, the mechanism by which wave properties arise from the rotation vector, angular momentum, of a photon is due to the alternating orientation of the rotation vector when its phase in our space is projected on a spacetime, as explained in Chapter 4. The case for electrons is similar but slightly different because electrons involve a double rotation of the rotation vector. To illustrate the double rotation of the electron's rotation vector clearly, it is diagrammed in a plane. It can be seen that three rotation vectors, x, y, z, revolve around each other like a binary star system, performing a double rotation. Next, focusing on rotation vectors x, red, and y, green, as in the explanation of the photon. In the case of a photon, the direction of rotation vector x is the same at any phase. However, in the case of an electron, rotation vectors x and y revolve around each other, yellow, so their orientation changes depending on the phase. When the phase circle in our space is expanded and projected on a spacetime, the orientation of rotation vector x points in the same direction in space, so wave properties do not appear. However, rotation vector x, red, is further rotating due to its orbital motion, gray, with rotation vector z, blue. Therefore, the orientation of rotation vector x rotates according to the phase of this orbital motion, gray, pointing right, up, left, and down. If right is positive and left is negative, it alternates between positive and negative. In this way, wave properties are generated from the rotation vector, even in the case of an electron. The electron's rotation vector is a collection, superposition, of angular momentum vortices, just like a photon, and the mechanism behind a mysterious phenomenon in the double-slit experiment is the same as that of the photon explained in Chapter 4. When passing through the double slit, the internal phase of the electron splits into two and causes interference. However, Because the electron is projected into spacetime probabilistically according to the density of the superimposed phases, it behaves like a single particle when observed on the screen. Note that, as will be explained in the following chapters, photon waves are projected in proportion to distance in Minkowski space, whereas electron waves are projected in proportion to the square of the distance due to the influence of the double rotation. The idea that an electron is a rotated photon has already been proposed in the Williamson and van der Mark (WVDM) electron model, so our space theory is not the first to suggest this. Additionally, the idea that Minkowski space is a secondary structure derived from a projection, which in our space theory is the projection of phase and rotation in our ether, has already been proposed in twistor theory. The Williamson-van der Mark electron model was published in 1997 by J.G. Williamson and M.B. van der Mark in their paper, Is the Electron a Photon with Toroidal Topology? In this model, an electron is defined as a single photon self-confined in a toroidal, donut-shaped closed path. It posits an electron is formed when a circularly polarized photon, electromagnetic wave, forms a twisted loop, resulting in a toroidal structure with a double loop. Because the electron is a rotating photon and the photon continues to circulate at the speed of light internally, this is consistent with Zitterbewegung, jittery motion, derived from the Dirac equation and the interpretation of matter waves. Furthermore, the property where the phase returns to its original state after a 4π rotation due to the photon's polarization on the torus and the double loop structure represents 1/2 rotational symmetry, which explains the electron's 1/2 spin. Additionally, the toroidal confinement of the photon's electromagnetic field explains the electron's charge and magnetic moment. The WVDM model is similar to the electron model in our space theory in that it considers the electron to be a rotated photon and explains the 1/2-fold rotational symmetry of electron spin through a toroidal structure. The WVDM model introduces nonlinear electromagnetic field for the photon to become self-confined. Similarly, our space theory posits that the rotation modes of the rotation vectors for photons and electrons change according to the magnitude of rotational energy. However, they differ in that in our space theory, the three rotation vectors in both photons and electrons rotate each other, meaning both are inherently in a state of self-confinement. Another difference is that in our space theory, as explained in chapters 2 through 4, charge, magnetic moment, and electromagnetic waves are all manifestations of the rotation vector, angular momentum. Twistor theory is a theory proposed by Roger Penrose in 1967 that attempts to unify general relativity and quantum mechanics. It proposes that the fundamental root of our world is not Minkowski space, but twistor space, which is a complex spinor space, and that Minkowski space is merely a secondary structure emerging from it. Our space theory shares the view that Minkowski space is secondary, as it considers Minkowski space to be a projection of our space, which consists of rotation and phase in our ether. The visual representation of a twistor by Ivor Robinson congruence, is depicted as a set of twisted lines in 3D space, a collection of non-intersecting straight lines. This represents how a point in 4D twistor space appears in our 3D spacetime. Geometrically, it has essentially the same structure as a stereographic projection of a Hopf vibration, and consists of a collection of lines spiraling around the surface of a torus, donut shape. These twisted donut-shaped geometric forms, such as toroids and tori, are concepts common to the WVDM model, twistor theory, and our space theory. The following table compares the Williamson and van der Mark electron model, WVDM model, twistor theory, and our space theory. Regarding space-time, the WVDM model assumes the ordinary Minkowski space as its foundation. In contrast, both twistor theory and our space theory treat Minkowski space as something secondary. As for the description of the electron, the WVDM model and R-space theory regard the electron as possessing an internal structure in which a photon circulates or rotates. Twistor theory, on the other hand, represents the electron as a mathematical spinor field and does not directly depict any internal structure of the electron. Regarding the origin of spin, the WVDM model and R-space theory interpret it as the manifestation of the rotational motion inherent in the electron's internal structure. In contrast, Twistor theory treats spin as a mathematical representation arising from spinor fields and twistors. As for the origin of electric charge, the WVDM model attributes it to the topology and circulating structure of electromagnetic waves, light. Pure twistor theory does not explain the origin of charge, but in the supertwistor framework, a charge-like quantity appears as a U1 internal symmetry. In R-space theory, as explained in Chapter 2, the idea is that the rotation vector, angular momentum, itself constitutes electric charge. Regarding the origin of the light speed constancy, the WVDM model holds that an electron is itself a photon, and therefore matter shares the same nature as light. In twistor theory, twistor space inherently possesses a mathematical structure that preserves the light cone geometry associated with the invariance of the speed of light. In R-space theory, as explained in chapters 1 through 4, the electron's rotation vector undergoes orbital motion and precession. The phase that can interact with the rotation vectors of electrons and photons is determined by the difference in their rotational symmetries. For this reason, an electron always observes the speed of a photon to be constant. Regarding the collapse of the wave function, the WVDM model treats the electron as a real electromagnetic field structure, a toroidal photon, and is therefore a classical, realist model that does not rely on quantum mechanical notions such as probability amplitudes, superposition, or collapse. Twistor theory, on the other hand, proposes the objective reduction hypothesis, in which gravitational effects render superpositions unstable and lead to wave function collapse. In R-space theory, the wave function corresponds to the superposition of phases of microscopic vortices, angular momenta, within the quantum interior of R-space, and the density of these phases, when projected into Minkowski space, appears as the pilot wave. What is projected is the angular momentum itself. The U1 symmetry shown by supertwistor is mathematically a first-order unitary group, a set of complex numbers e to the I theta with an absolute value of 1. On the complex plane, this is like a circle of radius 1 centered at the origin, which can be considered identical to the rotation vector in R-space. From this comparison, it can be seen that R-space theory is a theory that adds internal electron structure to twistor theory. However, interpretations regarding the collapse of the wave function differ.